Hello and welcome to week 6 of Science 137, Introduction to Meteorology. First of all, of course, those of you who are in active duty, thank you for your service, and I hope everyone in the course is doing well. Chapter 6 in week 6 is about air pressure and wind, and now we're starting to kind of go blow by by week. We had a couple weeks of temperature, then we had humidity, and we talked about how that was really important factor in weather outcomes. And then pressure and wind are very, very related. There's a reason they go in the chapter together. And on a lot of weather maps, especially early weather maps, pressure was actually the first kind of ingredient or variable that was considered. It is vital, it is very important to meteorology, and it's because, as you read into the chapter, it is the force that makes wind blow. And so a lot of the chapter deals with what is pressure, the notion of pressure as being essentially an average of the pressure that the column of air above you is exerting, mostly through its gravity, but also through whether it's sinking, increasing the pressure at the surface, or rising, lowering the pressure at the surface. Its relationship to wind is really kind of the crux of the chapter, and they go through kind of 4 factors that shape the direction of the wind. How strong will the wind blow, and from what direction will the wind blow? And the first force listed is the force that drives the wind. It's actually what forces the wind to begin, and that's pressure gradient force. And it is as simple as a fluid flowing from an area of high pressure to an area of low pressure. And if you want to try this concept out for yourself, tomorrow morning when you brush your teeth, squeeze the toothpaste. You are exerting pressure gradient force. You are causing toothpaste in the tube to move from an area of higher pressure to an area of lower pressure right out the nozzle. So that is pressure gradient force. It is literally a force, an apparent force that causes water, or not water, it can move water, but in this case causes air to move, or fluid to move, from an area of high pressure to an area of low pressure. So that's pressure gradient force. And one thing to remember is the tighter the pressure gradient, or the stronger the difference between high pressure and low pressure, the stronger the force of the wind. If you squeeze really hard on that toothpaste tube, you're going to shoot a lot of toothpaste out the nozzle rapidly. If you squeeze very gently, if the pressure gradient, if the difference between your squeeze and the outside of the nozzle is gentle, you're going to just shoot a little bit of the toothpaste, or it's going to be slow. And so we learn to be clean with the toothpaste by regulating the pressure gradient force. Now, that'll come into play when we talk about wind speed. So if we have a really powerful low pressure system, or a hurricane, or a tropical cyclone, that's why we get so amped up and so concerned with what is the central pressure, what's the lowest pressure, because that is one way of kind of estimating how tight, or how strong that gradient is from the low pressure in the center to the higher pressures in the outside. Again, the stronger the gradient, the stronger the slope, the stronger the difference from one place to the next, the stronger the pressure gradient force, and ultimately the stronger the wind is going to blow. The second force that acts on wind, again, it doesn't drive the wind like pressure gradient force, but it shapes the direction of the wind, is Coriolis Force. And there's a great description about how basically Coriolis Force is the consequence of us living on a rotating ball with stuff moving around. If you've ever been on a merry-go-round and you spin that thing rapidly and you try to move around, it's difficult. You get deflected off course because of the rotation. Well, Coriolis Force is kind of the big planetary version of that apparent force. We won't go into the math or the spherical geometry that they describe in the chapter, although that's good stuff to know. But what's important for the purposes of this course is Coriolis Force deflects objects in motion to the right in the northern hemisphere and to the left of their motion in the southern hemisphere. This effect increases as you go from the equator to the poles, and it also increases as the speed of the object or the speed of the wind increases as well. So to beat a dead horse even deader, PGF, or pressure gradient force, is the impetus for the wind. The stronger the pressure gradient force, the stronger the wind, the ultimate wind. And then Coriolis force is a major factor in deflecting that from its straight line motion to the right. And two other forces that have an impact on wind are centripetal force, and that's a physical phenomenon related to rotating motion. We won't go into that much in this course, other than to know this is one of the forces ultimately in all of this balance of forces that governs our wind direction. And the final force is friction. Friction tends to slow wind down, obviously, as air moves over the surface of the earth where there's a lot of friction. Things are slowed down there. So ultimately, all of this together, individually, it's a nice little physics exercise for each, but all of them together basically coalesce in, when we read a weather map, it results in air flows counterclockwise around a low pressure system. That's called cyclonic flow. A low pressure is an area of disturbed weather. It's also called a cyclone. So cyclonic flow is counterclockwise in the northern hemisphere, clockwise in the southern hemisphere. But in the northern hemisphere, if you see a big red L on the map, you'll know that winds are flowing counterclockwise around that low pressure system. If you see an H on the map in the northern hemisphere, you'll know that winds are flowing clockwise around that feature as well. And so even without looking at wind observations, you can start to look at these surface pressure features and get an idea of what direction the winds are from. If you have a low off to your west and you have counterclockwise flow around that low, you have a pretty good idea that winds are going to be out of the south in there. If you have a low to the west that's very strong, for example, and a high just to your east that's very strong, for example, that pressure gradient, that slope and pressure between those two is going to be really strong. You could expect strong winds, and we see that a lot in the plains during fire season. Really strong southerly winds with a strong low set up to the west, and that either fuels fires in the dry season, or it can pump a lot of moisture up through the plains to help fuel severe thunderstorms. So just knowing the basics of what is behind counterclockwise flow around a low and clockwise flow around a high, it has its origins in understanding the relationship between the balance of pressure gradient force, Coriolis force, centripetal force, and friction as well. The rest of the chapter deals with how we measure, historically have measured, and how we currently measure both air pressure using barometers and different kind of instruments related to the barometer, and measuring wind speed and direction using anemometers and prop vanes and different kind of instruments that measure wind speed and direction as well. But there's a reason these two are together. They are very closely related. When you have differences in pressure, you have wind, and so there's a reason that Aaron chose to put them in the chapter together. It's a smart reason as well. We have a pretty light week this week. We have just a map assignment, so best of luck to you on that. If that is unclear, please feel free to send me a message or drop something on the discussion board, and I can help out, or maybe even one of your classmates can help out before I can. Next week we pick back up with a few more exercises, and then we'll have a quiz over the first half or the last month or so of the course. Best of luck to you. Stay safe if you're overseas, and have a wonderful week, and we'll see you in this same place, I guess, next week.